Hello everybody, this is the video version of the meetup that we had yesterday, and the topic was AI in the cloud. But before we get started, who we are. So we are AWS Serverless Budapest, which is community, a user group that is backed by AWS, and we get together time to time to share ideas, dreams, fears, and thoughts, and more importantly, experiences that is related to AWS. Today, we are going to talk about AI in the cloud. I'm going to do it with my dear friend and colleague Adrián Mezei, and I'm Balázs Molnár. Both of us are cloud architects here at Snapsoft Ltd. So we had this meetup yesterday. It was an in-person meetup, and you already submitted quite a few survey feedbacks, and thank you very much for that. The survey is still open, so you can submit feedbacks, especially that these feedbacks are extremely valuable for us. These feedbacks made us choose the topic AI in the cloud, despite of the fact that neither of us is data scientists. So as you might experience today, we are not going to talk about how to build neural networks or how to optimize hyperparameters. We are going to more focus on AWS tooling and AWS services that can help everybody to do the heavy lifting when it comes to machine learning. And also, the other focus is going to be those AWS services that are high-level services, so you don't need any expertise or machine learning experience to start using it. And these are off-the-shelf solutions, so you can start using them immediately. So a couple of words about the agenda. I'm going to do a really short introduction about the opportunities that you've got if you are talking about AI in the cloud. And then we will dive deep into the high-level AI services. More accurately, Adrián will talk about Rekognition, Textract, Amazon Comprehend, Amazon Polly, Amazon Translate. And in the end of this session, I'm going to build a fully functioning chatbot that helps us ordering pizza, which is pretty useful. And hopefully we're going to have some fun together. And yesterday, after this, we had some networking session. This is a benefit for those who come in person. All right, AI in AWS or AI in the cloud. So before we start talking about things in AWS, let's step one back and ask the question: is that why we would like to do machine learning at all? So what we experienced is that at the dawn of the cloud computing, businesses started migrating their computation workloads and their data to the cloud. And they kept on collecting data because data storage is pretty cheap. So now businesses ended up having lots of data property, but they didn't really utilize this. They didn't really make value out of it. I believe that was the thing that AWS realized like years ago when engineers at AWS started developing tools and services that can help businesses to utilize their data. So they started building AI and machine learning tools to solve these problems. So what kind of problems can be out there? So to do any machine learning training and to solve your business problem in machine learning, first you need data. This is something that you can't really work without. As I already mentioned, there is lots of data in the cloud. The problem with this data that is usually not well structured, not well collected, it's distributed across departments, software systems, applications, They usually have different shape and format, and so it can be challenging to have them in the right place. AWS has quite a few services that can help you with storing this data, which can be almost any amount, and then AWS can help you transferring first and then transforming the data in a shape that it has to be. And there are quite a few services that can handle a massive load of data and real-time data too. So once you have the data in a place where it has to be, then obviously that's still not enough to give it to a machine learning training algorithm. You need to understand what the data is, and also you might want to do some feature engineering to collect the data that you really need to train your model. So there are quite a few easy to use analysis tools that can help you accessing your data and analyzing it. There are services that can help visualizing your data, and also services that helps you with real-time incoming data analysis or big data processing. You've got tools to do the feature engineering as well, so you can handle missing data, outliers, biased data, and you can prepare your data set for machine learning training. And once you've got this data, you can start thinking about what's next. So obviously you would like to train a model, and then you want to deploy this model and start making decisions based on this model, or inference, or give it to your customers to give value for them. So on AWS, if you have a pretty unique problem and you have got some machine learning expertise, but you still don't really want to deal with infrastructure provisioning, capacity planning, highly availability and durability problems, I would highly recommend going with the SageMaker family. I said SageMaker family because there are quite a few SageMaker services out there in the SageMaker portfolio that covers basically the whole iterative journey of the machine learning problem solving. Starting with storage, like SageMaker Feature Store, you can then think about feature engineering with data wrangler, or handling missing data, like SageMaker Ground Truth and label generation. And moving forward with machine learning training, with over 15 built-in models, and with optimized workloads for the major frameworks. So SageMaker is a pretty handy go-to service collection that you should definitely check out if you would like to have, if you want to use your machine learning expertise but don't really want to deal with infrastructure provisioning. SageMaker also helps you with testing and monitoring your models, and also it can run and host your trained models. So again, it's a pretty handy tool. But if you don't have machine learning expertise and you still want to utilize AI in your product, you can go with one of the so-called high-level AI services. Your problem has to be mainstream enough to have an off-shelf solution from AWS, but as you will see soon, there are quite a lot of AWS services that cover most of the common business use cases out there. So if you go with these services, you don't need machine learning expertise. You don't need to deeply understand how like a neural network works, and sometimes you don't even need to write too much code. You can pick from one of the off-shelf algorithms and solutions. These solutions, again, as you will see soon, are usually customizable, so you can fine-tune it to your own business problem, and basically they are available for you to use right now. So I'm going to pass the mic to Adrian to dive deep into the world of high-level AI services.
So let's start with the high-level AWS AI services. So today we have brought you some of the most interesting services. Maybe these are mostly the mostly used services, and we are going to focus around the language AI services today. That's because previously in our one of our last meetups, we have already built a chat application, the so-called Awesome Chat application. That's something that you can also find on GitHub. And that's where we implemented some of the features that we are going to show you today. This is going to be like translation, sentiment analysis, and Polly, for example, that can read you text out loud. And these are things that you can try out on your own. But for this, you need to go to GitHub, check out the repository, and deploy an application from that. So now let's talk about these services generally, because there are a few things about them which are common. These are not service specific, and if you know these, when you go to a new AI service, you will know how to deal with it. For example, these high-level services come with pre-trained models. So AWS provides frequently used use cases. These models are ready for those use cases that many people have already used, and maybe you will need some of these as well. And you can use them right away. There is nothing you should do in the background. You don't need to create your own model for this. You don't need to be a data scientist to have this up and running, and there are no upfront costs for these. When you would like to use a service like this, you have two options. Basically, you either do it real time, or you will have an asynchronous job running in the background. These are separate use cases because, for example, you have a web page for which you need a real-time response when you would like to do sentiment analysis or translation, for example. And in other use cases, when users upload photos, for example, that you would like to handle asynchronously, then that's where you can create asynchronous jobs in the background, and when they are ready, you will handle the results. Also, when you use these services, the AI model-based response that you receive from AWS, they are going to have confidence scores. And these confidence scores are what you would think. They are confidence values based on how confident the model is in the response that was given to you. So you can say that when you would like to detect a face, for example, you get a confidence value of 0.7, which means that it's 70% sure that the given item is a face. And then maybe you do something depending on this value, because it's below a threshold. Then you say that, okay, it's not so certain that it's a face, then you do something differently. If it's above the threshold, then you are confident and you can go on with your business logic. When you use these services, these are the high-level AI services are used by simple API calls, which means that the libraries are already ready. They are there in AWS. And if maybe you are used to infrastructure deployment or resource creation in AWS, but in these cases, these models are ready. There is nothing that you need to provision. There is nothing that you need to configure. You just use the library and the corresponding function that will give you the proper result that you would like. One more important thing generally about AI services, these AI services in the background use your data. Of course, you upload an image, text, or something that is going to be analyzed. And in the background, AWS may use these data for improving their AI models and giving you better answers by time. If you would not like to be part of this, then you can explicitly configure your AWS account so that it opts out from this feature, and then you can use these services in the same way, but you need to configure it. Okay, so the Awesome Chat application that was created previously is this left image that you can see here, and a new application is the right side, that you can see that more features are implemented: the translate, the sentiment analysis, and the speech functionality. That's where you can use these services. If you have an AWS account, by the way, you can try it out on the console as well, and that's where I will show you a few things. So first, let's start with Rekognition. Amazon Rekognition is an object, scene, and text detection service that we can use to analyze photos and detect certain pre-trained model used labels within them. It has a lot of functionalities. We will see this in the Amazon console. But now first, let's have a look at some of the features. So as you can see on these images, for example, in scene detection, you can see a detected rock, for example, detected that it's outdoors. A mountain bike is detected as well, and so many other things. In case of, for example, a facial analysis, a model is going to detect you, for example, an interval of age, glasses, facial hair, mouth is open or mouth is not open, and things like that. You also have a feature for face comparison, for which you can provide two images or multiple images. One is where you're going to have the reference face that you would like to find on the other images, and then the other images where you search for this face. Also, you have celebrity detection that you might be interested in, and also there is a special feature. This one is only for videos. There are a few models that are trained specifically to detect person, packages, or pets, or some of the combination of this, like person and packages. Here you can do this in real time, so when you have a video stream, you can detect these items in real time and use it to do certain actions. You can also define custom labels. So for example, business-specific use cases. You might want to train, for example, these models to detect some objects that are related to your business, and those are unique, and you have a lot of images, so that can be used for training these models. So we are here in the Rekognition console. What you will see, here is an example image. Here you can see which objects are detected. Like, for example, from the image, it's a neighborhood or a city, a road, a street, a person is detected, a car, and so on. So the format of this is very simple. The request contains an S3 bucket and the name of the image that you're going to use, which is here you can see the path of the object within the S3 bucket. In the response, it's quite straightforward. So you receive this information in forms of labels. Labels contain a name, a confidence value that I've mentioned before, and in some cases not only categories, but it also contains bounding boxes if it's meaningful. So for example, when a person is found in the image, you can see the bounding box, where is it located within the image. So here, for example, you can see a person, a skateboard, car, wheels, and so on. So let's jump to image properties, which is a quite new feature. Here you have image properties like dominant color, like how blur the image is, the brightness, the sharpness, the contrast. So these attributes may be meaningful in your application. Image moderation is our next feature here. Here is a picture on which no moderated content is found. But if we have a look at the next image, here we have 3 moderated labels given back. So one is a suggestive, female swimwear or underwear, and revealing clothes. Here we also get the confidence scores. And here we can see the format is pretty much the same. The request itself is also the S3 object in a similar way, and we can see that all the values are here in a similar label format. Let's continue with facial analysis. Here you will see that we receive all this data, an age range, whether she smiles or not, wearing glasses, also the confidence values here. And the request and response itself is very similar. We have all these bounding boxes, labels, in the cases where it's meaningful, and we get a lot of identified items here. Celebrity recognition is also interesting. Some of the celebrities are, they have models trained, and some of the celebrities can be detected. For example, Jeff Bezos. Here you also get a confidence value in a similar way. The next feature here is face comparison, which might be which you might have heard before. So maybe you are familiar with it from other applications. It does the thing when you label, for example, an image, you give it a name, and you would like to find the same person on other photos. Then it is going to analyze your photos and say which faces are the same, which are a match, and which do not match. So here you can see one image. This is the reference face, and then we use the comparison faces in other images, and here you can see which faces are a match and which are not. Also, we have another example here, which is pretty much the same. Of course, here in this case, you are going to provide two images, and these two images are the target and the source image that are analyzed. And let's have a look at one more feature here, which is text recognition in images. Texts are extracted from the images, and they are processed very similarly. As you can see, you get a confidence value here as well. You get a type, for example, line, and you also get the bounding boxes or polygon, where is it located within the image. Okay, so that's pretty much what you can expect from Rekognition. So the next service is Lookout for Vision, which is in comparison for Rekognition is a bit different because it uses industrial images. Most of the use cases are industrial production lines where you can improve your production quality. Here, for example, you can identify scratches. For example, here you can see a door of a car has scratches. You can identify these defects. Or you can maybe identify fabrication and assembly process defects, where, for example, missing components or appearing components can be identified. So these are usually outliers. So they are identified from the pattern, the repeating pattern that in the manufacturing process comes after each other in a sequence. And when you have an outlier, that's identified, and then you can improve your industrial process using Lookout for Vision. So let's have a look at our next services. Here we have Textract for first. Textract is going to extract text from images. Here you are going to be provided with special models by AWS. For example, you can have a general document analysis, but you also have the possibility to analyze ID cards and expenses. These are specially trained models, and they perform much better in these use cases than a general text recognition. So let's have a look at this as well. So in case of Textract, here we have a demo from the AWS console. If we have a look at a document that is analyzed, it has all the fields extracted here in a form of list of strings. This is generally when you have a document is going to be analyzed like that. It can also grab form items, it can also grab tables, and it can also find some queries here. It is also capable of identifying signatures. Let's have a look at one of the special use cases, for example, expense analysis. Expense analysis have two main parts here. The one is the summary field. The summary field has a header and the footer part, and it contains all the other information that is not the items itself within the receipt. And the line items are going to be provided in another field here. Here you will get each line, the name of the item, and in this case, the price of these items. And the next feature here is ID card analysis, where you can see the ID card fields analyzed, for example, the first name, the last name, city, address, and so on. This might come very useful in your applications. And now, let's have a look at Comprehend. So what Comprehend does? Comprehend is going to detect parts of the text. It's going to have entities. What are entities? Entities can be names. Entities can be locations. It is going to also detect your key phrases, PII, language, sentiment, and also targeted sentiment, which is going to be the sentiment against detected entities. This is interesting because the simple sentiment which is detected, that's for your whole text in one. So that's a general sentiment of the text. And it's going to also provide you language syntax details. So when you would like to detect something business specific again, you have the possibility to have your own data and train these models for your specific use case. And here you can provide, for example, custom entity recognition, which in this case is you can define two entities like engineer and manager, and then you give a list of values, for example, names in this case, and you train the model for it. And then within your text, the engineers and the managers are going to be detected as specific entities. Also, you can do document clustering, which is when you provide a bunch of documents. Comprehend is capable of separating and grouping these documents into separate groups, and based on the content of the text that you have provided. And here you can also have your business specific use case because, for example, you can have documents in categories like comedy or drama. And this is also something that you need to pre-train. You provide dramas and you provide comedies. And afterwards, the model is trained. Then you can have the next document, and Comprehend is going to tell you whether this is a comedy or a drama. And to make this whole workflow easier for you, now we have flywheels, which is a tool that can help you from the beginning to the end in the whole journey of this model creation, because you need to provide the data, you need to tune it, you need to create versions, you need to publish it, and this whole workflow is made easier with flywheels. So now let's have a look at Comprehend in the AWS console. So here is a short text. Hi, I would like to book another seat for flight Z53892. It turned out that Sophie would also like to come with me to Dubai. So let's analyze this text and see what we have. So for example, we have three entities identified here. We have the flight number, which is another type. We have Sophie, who's a person, and we have Dubai, a location. Also, we have the corresponding confidence scores as well. Here we have key phrases. Here we can also see some of the entities that were detected and some other phrases as well. The language is English with a 99% confidence, pretty straightforward. And the PII in this case is Sophie and Dubai. And here we have the sentiment analysis. The general sentiment of this text is identified as neutral, and we also have confidence scores for the other categories as well. Targeted sentiment is targeted against entities. So here you can see a list of entities and the primary sentiment against those entities. And in the syntax, you can identify parts of the speech. Okay, let's jump into the next service, which is Amazon Polly. Polly is a service which is going to transform text into lifelike speech. Let's listen to one of them first.
To be, or not to be, that is the question, whether 'tis nobler in the mind to suffer the slings and arrows of outrageous fortune, or to take arms against a sea of troubles and by opposing end them.
Maybe this quote is something you have heard before, may it sound familiar to you. So this, what you have heard, was a neural engine, because Poly comes with two types of engines, a standard and a neural. The neural engine sounds a bit nicer, a bit better, but it is also more expensive. So just for comparison, let's listen to a standard engine first and then to a neural. So now the standard engine.
What a wonderful day. The sun is shining.
Okay, and now the neural engine.
What a wonderful day. The sun is shining.
So of course, it depends on your use case. Maybe in some cases, the price is more important for you, but in some cases, maybe the quality of the sound. So Poly comes with 90 voices in 36 languages, and Hungarian is sadly not included. But for international languages, here you can use all the others and make use of Amazon Poly. Also, Amazon Poly comes with a lot of cool features that you might use as well. You can define SSML enriched text, which means SSML is the speech synthesis markup language, and you can define ways to have your words pronounced. So, for example, you can define emphasis to emphasize a word. You can define a break. You can say that you would like some part of the text to be whispered. And also, you can increase the volume or increase the speed of certain parts of the text. Here you can see an example, and now let's listen to it.
Sometimes it can be useful to increase the volume of certain parts of a text or slow down the speed for better understanding.
So you probably get it, how you can use it. Also, in this case as well, similarly to the other services, you have the possibility to customize some features of Poly. So, for example, you can define your own pronunciation lexicon. Maybe you have special use cases, you have some words that are pronounced differently, or you would just simply like to define it. Also, abbreviations can be defined in the text that are going to be resolved in the spoken speech. So let's have a look at the lexicon. It's an XML, so just for an example, here you can see the phoneme of a word, pecan. And now, one of the last services is going to be transcribe. Transcribe is the exact opposite. Transcribe is going to turn speech into text, and then you can use all the other services that can deal with text, like sentimental analysis and so on. Here, Hungarian is also not supported, sadly, but there are 39 languages, so in most other languages use cases, this is going to be very useful. It also provides you dominant language detection, so you don't need to wire other service, for example, like Translate for this. It's going to be provided you out of the box, and it can do speaker diarization. Speaker diarization means that when you have multiple people talking in a conversation, then you can identify the text from each of them separately. This might come pretty handy in some cases. Up to 10 unique speakers in case of transcribe. Also, here you can specify custom vocabulary or custom model that you can use to train the service for your use cases, and you can also do vocabulary filtering. You define a list of words and you either remove them, mask them, or simply tag them within your text. Transcribe also does PII identification, and it only does it in English. And now let's have a look at the Amazon Translate. Amazon Translate is a translation service that you can provide text. It is going to translate it to you in 75 languages. it does automatic language detection, of course, and you can also define parts of the text that you would not like to translate. This can be very efficient in cases when you would like to not translate, for example, terms which are names of certain places in the language of the source of the text, and after the translation you would like to have the original name as well. When some languages are formality supported languages, in this case there are 11 languages, and here you can define whether you would like the translation to be formal or informal. Also, Translate comes with profanity masking capability, which means that profane words can be masked in your translation. Also, you are provided with a batch translation or real-time translation that you can use, for example, in your web pages, and make use of the whole feature set as well. So let's have a look at Amazon Translate. So here I define the translation to Hungarian. Take me to the nearest restaurant, please. At the end of the text, there is a do not translate this part, which is not translated. Here in the additional settings, we can see that here we could have our custom terminology, or we can use formality, for example. Hungarian language is not supported in formality configuration, so if I configure it to informal or configure it to formal, the translation is going to be the same. Let's try with the German translation, because German translation supports formality, and here we can see the formality is selected, so the bringen Sie mich is the formal Sie in this case. This is a formal structure in German. And we switch it to the informal, then it's going to be the bring mich bitte, that's the informal version. And now, let's have a look at Amazon Lex. Lex is a service from which Balázs is going to tell you a few words about, so I hand the mic to him at this point.
All right, let's talk about Amazon Lex V2. So Amazon Lex enables any developer to build conversational bots quickly. It uses automatic speech recognition and natural language understanding to create speech-language understanding. What it does basically is that it takes some input, it understands the intent that is behind the input, and it fulfills the intent by invoking a Lambda function. It supports both speech and text. Obviously, it's well integrated with other AWS services that Adrian talked about before. So it can understand your speech with transcribe and answer with Poly. And it is also really well integrated with contact center services like AWS's built-in Amazon Connect. It has 3 built-in channels that you can use off shelf. This is Facebook, Slack, and Twilio SMS. But you can also integrate your own chat application via AWS SDK, or basically AWS API. That's what we did, by the way, yesterday in the demo application. Amazon Lex supports 17 languages with several locales. For example, the English language has 5 locales like Australian English, American English, British English, and so on. But unfortunately, it doesn't support Hungarian. So let's move on the AWS console to take a closer look at Amazon Lex. So this is basically the landing page, and as you can see, Lex is built up by bots. Here you can start from a pre-built solution that AWS prepared for us for like the most the most common use cases. But you can start from scratch as well. So as I said, Amazon Lex is built up by bots. If you are a bigger enterprise, from now you can build a network of bots as well. All right, let's create a bot. As you can see, this is the pizza order demo that we created today, yesterday together. I'm gonna create a bot and walk through the surface and get deeper into how a bot builds up. So I clicked on create a bot. I'm gonna create a blank bot and name it to be pizza order bot demo 2. I'm gonna add a description, a bot that demonstrates how Lex works. I'm gonna ask AWS to create a configured role for this bot, and I'm gonna say yes to the Children's Online Privacy Protection Act, as we won't give this bot to kids under 13. Here I leave the idle session timeout to 5 minutes, like leave the default. I click on next. And now I've created a bot. Let's add a language to the bot. So I'm gonna go with the default US English, and here the intent classification confidence score threshold is remain the default as well. Basically, this is the threshold that tells Lex if it can match to an intent. We will see soon what an intent is. So I click on done. So we end up in our pizza order bot demo 2 chatbot. And now let's see how a bot builds up. So I'm gonna leave this intent definition now and go back to the main page of this bot. So each bot has a bot version. First, we've got a draft version, but we can publish new versions if we want to deploy something new. And then each version has at least one language. Here we selected the American English language, and within languages we can define intents and slot types. In an intent, we can define something that a chatbot can do for a customer. And what Lex does is basically it collects some input text or speech, and then it tries to understand the meaning of this text or speech, and it tries to match on an intent. Once it's matched to an intent, then its biggest goal is to reach the fulfillment state, and to do so sometimes it has to collect extra data for the fulfillment logic. These extra data is usually defined in slots. We will see soon what a slot is. And we can define the type of this slot. But once Lex collected all the required slots and perhaps asked for a confirmation from the user, then it triggers the fulfillment, usually lambda function, which lambda function then receives all the data that is connected to the given session, the slot values, and anything else that might be interesting, any other metadata. And then this lambda function can do what it has to do to fulfill the intent. All right, now back to the new intent. As you can see, what we get from Amazon is a fallback intent. This is the intent that Lex used to match on if it cannot find out what a user would like. And then we have a new intent that is created for us just to have something to begin with. So let's try out the new visual builder and build our chatbot there. So first, we got one block. So in this canvas, we can use blocks, and the first one is the start block. Chatbot intent always has to contain a starting point, so this is the start block. Let's edit the start block and name the intent as pizza order intent. We're gonna ask Lex if it could match to this intent to add an initial response. And to make Lex more sophisticated, we are gonna configure two options for the response. So the first one is, hi, I can help you with the pizza order. That's the first one. Okay, I can help you with, that is the second one. All right. And to end the conversation, I'm going to place an end block here. And once Lex came back with the initial response, we will immediately go and close down the conversation. So I'm going to save this intent and build a chatbot model. Yeah, and we received an error, which is expected. Expected because to enable Lex to find out what the customer intent is, we must specify sample utterances. These are sentences that the chatbot training algorithm uses to train a model that can match on intents. So I'm gonna define here a couple of sentences. So let's say I want to order pizza, please. I want to order a pizza. Can I get a pizza, please? Oops. I want to order a size, pizza kind. These are gonna be slots later. Pizza. I want to order a pizza kind. Pizza. Can I get a size, pizza kind, pizza, question mark. Can I get a pizza kind, pizza at time? Time is gonna be another slot. Now I'm gonna save the intent. And at this stage, Lex should have enough knowledge to train a model. So let's click on build. It usually takes less than a minute to build a new model until the model is not too big. So let's wait it off. And then, yes, Lex could successfully build a language model here. Let's test it. So, hi, and I would like to order a pizza. Okay, I can help you with that, meaning that Lex could match to an intent. Let's do like a negative test. So, hi, I have a really good day today. yeah, it matched to the fallback intent because it couldn't find out what I would like to do. I would like to highlight the fact that I used this polite "I would like to order a pizza" sentence, but there was no "would like" here in the sample utterances. So the language model behind Lex could understand what my intent is, despite of the fact that there was no word matching here in the list of samples, which is pretty cool, I think. Okay, so this is good, but it's not really useful because it is not enough to fulfill an intent. We need to get more information about the pizza that a user would like to have. So I go back to the main page of the bot, and I'm going to define slot types. So first of all, I'm going to define size, and I restrict slot values to be large, big, maybe, huge, massive as synonyms. Let's set a medium size option as well, and a small with synonyms of little and tiny. Save the slot type, and now I'm going to create another one, which is the pizza kind. I'm going to restrict the values of pizza kind to cheese, veg, meat, pepperoni. That could be salami as well. Save this slot type as well. Okay, let's go back to the intent. See the visual builder. So we had this starting point and the ending point and the connection. I'm going to remove the connection and add a new block, the get slot value block. I click on edit, and the slot name is going to be size. The type is size. We expect Lex to find this, find out what the size should be. We accept one answer to this. We don't need to hide the value of the size, and let's add a slot prompt, which could be what size of pizza would you like? So this is going to be the question that Lex will ask if it would like to find out the size of the pizza. So we could define here sample utterances as well designated to this slot. I'm gonna do it now. I think Lex will find out without this as well. So I'm gonna now connect the output of start with this block. I will add a go to intent block as well here to handle the failure. So for now, the failure is gonna be handled by the fallback intent. So we just simply redirect to the fallback intent, and let's add another slot. This slot is for pizza kind, which will have the pizza kind type, and the question should be what kind of pizza would you like? Okay, I'm gonna connect it into the network. And I add the last slot value that we would like. And this is going to be the time. But for this, I'm going to use a built-in slot type. As you can see, there are quite a few built-in slot types from Amazon. And we will use the amazon.type here. Yeah, we set it as a required. And the question is going to be following. When would you like to get the pizza today? Okay, I'm gonna add it to the network. Again, failure is handled by the fallback intent, and connect it to the end. And now, in theory, I filled out everything, so everything has a name, question, and everything is connected to the network. So I'm gonna save the intent, reorganize the net a little bit, and build a new version of the bot. So what we should experience is that after Lex found out what the customer what the user intent is, it will start collecting information about these slots. There is a little inspector here in the test window, so we can see what the status of our slot is. So, hi, I would like to order a pizza. So we have the initial response, and then it started collecting the information. So it would like to know what size of pizza I would like to have. Let's say I would like to have a huge pizza. So it recognized that we used a synonym of large, and it saved the large to the slot. What kind of pizza? I would like to have a veggie pizza. And when? I would like to have it at, let's say, 5 p.m. Okay, and as it found all the missing slots, Lex fulfilled this intent. Now let's add a confirmation question. I'm going to close these windows now and add the new block, which is the confirmation block. Here in the confirmation block, I'm going to ask the customers if they are okay. So, are you okay to order a size pizza kind pizza? If yes, then all right, that's going to be our answer. If no, then okay, the request won't be submitted. That's going to be our answer. So let's add it to our network here. But no matter if they say yes or no, we are just gonna end the conversation. And if there was an error, we just simply go to the fallback intent. Right. I'm going to save this intent now and build a new version. I mean, I do some housekeeping here in the canvas and ask Lex to organize my blocks nicely. And we already have a brand new model here. So let's test it. Hi, pizza, please, to keep it short. A large one. Veggie again. When would I like to get it? Okay, it's fine if I get it at 6 p.m. Are you okay to order a large veg pizza? Yes, sure. All right. Okay, so what happens if I define the slot values in the first sentence? So when Lex matches on an intent. Like an example, like, hi, I would like a large salami pizza. I mean, large salami pizza. So it's not too clever, not configured properly, but we can easily help with it on this. So if we come back to the sample utterances and change the previously defined weird words to slot values, which I'm gonna do shortly. And rebuild the model. Yep, I had a typo here. Let's save and try to build it again. Okay, now with the new model, let's test it again. I've got some UI glitch here. But a good old refresh can handle anything. So, hi, I would like to order a huge salami pizza, please. Okay, so when would you like to get the pizza today? At 8 p.m. And as you can see, it recognized the size and the pizza kind. So, yep, now let's say now for now. Okay, the request won't be submitted. So far, so good. So now let's add the last step, and this is basically the whole purpose of this intent, and this is the fulfillment block. As you can see, you can only add one confirmation and one fulfillment block per intent. So this block is gonna be the one that will trigger a Lambda function when Lex could find all the missing slots. So in this demo, I'm not gonna create a Lambda function, but I will receive a nice answer, or sorry, send a nice answer, which is for the positive side. We have submitted an order for a size pizza kind pizza, and to test the time slot as well, that you will receive at time. failure would be like error while submitting your order. This is when a Lambda function returns with an error. And then we could have a timeout response, which would happen if a Lambda function can't fulfill the intent in time. So let's add this last block to our bot. So for the success outcome, we end the conversation, and if there was a failure or a simple timeout, then we'll just go to the fallback intent. I'm gonna reorganize the whole network of blocks and save the intent. Okay, let's build the final model that will function as a pizza ordering chatbot. While we do that, a couple of words about deployment. So Lex is pretty similar as how Lambda works. So basically we deploy both versions, and we can create alias as a pointer, like alias could be like prod, and we can define where an alias points to. So basically a prod can point to version 1, and if we fine tune our model a little bit and we want to release a new version, we can change the prod alias pointer to version 2. This is good because the consuming application, so the application that might use this bot, doesn't have to change. So we can save the alias ID and the bot ID, and even though we release a new version, there's no need to change the consuming application. So the bot is built, and the final conversation Hi, I would like to order a big veggie pizza. When would you like to get the pizza today? Well, let's say now. Yes, I'm more than happy to order a pizza. And we can see a confirmation message that we have submitted an order for a large veggie pizza that we'll receive at this time. Okay, let's do the final steps and release this version. By the way, you can use this draft version for testing, but it is rate limited, so you can send 2 messages, or it will handle 2 messages per second. So it's really not for production load, but it's pretty easy and simple to create a new version. You just click on create version, select the language, and click on create. And then if you want to create a new alias, then just simply click here, create alias. That's going to be our prod alias, and we'll point it to version 1. Click on create, and here it is associated with this version. With this, I would like to thank you for your attention, and if you haven't done that before, join to our meetup community to have sessions like this in live as well.